of the form ax squared plus bx plus c. So that's your standard form of a quadratic. These are not equations. These are just going to be expressions. You won't see any equal signs at all with anything we're going to do for the next couple days here. But the easiest way I have ever learned how to factor. Okay, you are going to find two numbers, and to get the two numbers, you're going to take, today is going to be a little different because we're going to have the a value in every single one of these. You're just going to see this is going to start with just an x squared. So the a value in everything we're going to do today is just 1. But you take the first coefficient times the constant, so a times c, whatever that is, that number, you're going to multiply to get that number and add to get whatever the b value is. If you can find two numbers that fit both those requirements, and there's only two that'll ever work for both, those will be the two numbers you want to use to write your factored form. Okay, so I just made, you don't have to make a little chart or anything like that, but I just made that for these first couple questions just to kind of walk through these really slowly. So I've got x squared plus 10x plus 24. That's standard form. It's all multiplied out. The factored form here, I'm going to come back just real quick. The factored form is going to be like two little sets of parentheses that we could FOIL back to get that problem. So we're going to work it to factored form because that makes it easier to solve once we get to a quadratic equation. So your a times c here would just be 1 times 24. So I got to think of two numbers. When I multiply them, they would give me 24. Same two numbers, they add to give me the b value, which is 10. There's only two numbers that'll fit both of those requirements. And just while I'm thinking about it, to set up the factors, all you're going to do, you're just going to take the first term, which is x squared, and you're just going to drop the squared, and you're going to write that at the beginning of each of the factors. To fill them in, all you got to do is tell me, can you think of two numbers that if you multiply them together, they'd get you 24? The same two numbers, if you added them together, would give you 10. Yes. Yes. Okay, and you don't have to write this out, but 6 times 4 is 24. 6 plus 4 is 10. It has to fit both requirements. There's sometimes these can be combinations that maybe works for one but not the other, has to work for both. So when you write this in the factor, you just do 1 is a plus 6 and 1 is a plus 4. Ooh, sorry for the noise there. Now, this is the actual answer to the question, but I just want to show you on this particular example just real quick. This is the same as x squared plus 10x plus 24. It's just called factored form. What we had in the original problem is called standard form. If you were to FOIL this back out or draw yourself a box, just real quick, x times x would give you x squared. X times 4 would be plus 4x. 6 times x would be 6x. And 6 times 4 would be 24. So this is the reason that that will work, because you end up multiplying these two numbers, the 6 and the 4, that gives you the constant, so it's multiply to get that, and then add to get the number in the middle, because if you guys see what happened here, I did x times one of those numbers, and the other x times the other number. If I add the 4 and the 6 back together, that adds back to the 10x. So that's why it's multiply to get the number at the end and add to get the number in the middle. So that would give you back the original problem. This is your answer to the question. That's your factored form. That is the fastest way I have ever learned to get you there. So let me try this one here. So a times c here just would be 1 times 6. So I got to think of two numbers that if I multiply them together, I get 6. And if I add those same two numbers together, they would give me the b value, which is 5. So while I'm thinking about that, I'm just going to do my two little sets of parentheses and just take that first term, it's x squared, drop the squared, and you just write that at the beginning of each of the factors. Can you guys think of two numbers when you multiply them, you get 6, the same two you add, get 5? 2 and 3. Okay, and again, you don't have to write this out. I'm just kind of showing you this real quick. One's going to be x plus 2. One is going to be x plus 3. And just, you don't have to write this if you don't want to. It doesn't matter the order. So if I wanted to put the x plus 3 first and the x plus 2 second, that's exactly the same answer. So it doesn't matter the order that you put them in. It just matters that you have the two correct numbers. So either way, both of those are correct. Is anybody having a question? Okay. Oh, I didn't even explain this at the top here. So this first example, you'll notice both of these examples just have pluses in between the terms. So this says A is 1, this says C is greater than 0. That just means the constant term was positive, and B is greater than 0. That means the term with the X was also positive. So I'm going to give you the three different scenarios you can run into. This one in example 2, I always find that this one can be kind of tricky. So again, the A value for all the questions we're going to work on today is going to be 1. This says your constant, your C value is greater than 0. That just means the last piece of that quadratic is going to be positive. The B value is less than 0, so that just means the term in the middle is going to be negative. So these are a little bit tricky. So I'm going to multiply just 1 times 33. So I'm going to multiply to get 33. And I'm going to add to get the number in the middle. And when we start having negatives for these, you kind of have to experiment a little bit maybe with should the factor be positive or negative. So same thing, I'm going to just draw my little parentheses here, and I'm just going to start each of them out with an X. Can you guys think of two numbers? If you multiplied them, when you multiplied them together, they'd give you positive 33, but if you added them, you'd get negative 14. What do you think? Yes. Okay. So and you don't have to write this, but negative 11 times negative 3. That's going to give you positive 33. Negative 11 plus negative 3 gives you a negative 14. So when you write the factors, if you use a negative, you just do a minus. So one of these would be x minus 11. The other would be x minus 3. So if this is your situation, both factors will always be negative. That's the only way that you could multiply to get a positive number on the end and add to get a negative number in the middle. Both of them are going to be negative. All right, so we're just practicing a couple of these just for some extra practice here. All right, so here I got to multiply to get 12 and add to get negative 7. Can you guys, I'm just going to start my factors. I'm just going to write an x and an x. Can you think of two numbers, if I would multiply them together, they'd give me 12, but if I added them together, I'd get negative 7. And if you ever get stuck, like if you're ever like, I don't know, I just start writing out factors like this one of 12. So I've got like 1 and 12, 2 and 6, 3 and 4. Those are all my options that I have to work with. I just need a combination that's going to multiply to give me positive 12, add to give me negative 7. Perfect. So one of these, x minus 3, one of them, x minus 4. You can switch the order. It doesn't matter which one goes first, which one goes second. And I do find if I get tripped up, like if I write the factors out, write out my options, that usually can make it a little bit more obvious to you what you want to pick. All right, so I'm going to try one more here. This one, I'm going to multiply to get a times c, just first times last would be 1 times 81. So multiply to get 81. And I want to add to get that number in the middle, that b value, which is negative 18. Can anybody think of two numbers when you multiply them, you get positive 81, you add them, you get negative 18? Yes. Okay, now this one's a little bit weird. So they're both going to be x minus 9. Negative 9 times negative 9 to give you the positive 81. Negative 9 plus negative 9 will give you the negative 18. Does anybody know, is there another way I can write the x minus 9 times x minus 9 if they're both exactly the same? Okay, this is okay. If they're exactly the same, you can squish them together because you're just multiplying the same thing by itself. So I can write that as x minus 9 squared. Now, both of the factors have to be identical for you to do that, but that is totally something that you could do to kind of shorten your answer a little bit. Does anybody have a question? All right, now this is the last possible case that you could run into for the way these can be laid out. And this one, the b value could be positive or negative, but this one says the constant term is less than 0. So anytime the constant term is negative, that's what that means, less than 0. To get two numbers to multiply to get you a negative number, which is what we're going to have here, you're going to have, I'm just going to write this, one positive and one negative factor. So these can be a little bit trickier to find out the combination that you need. Like one of them will be a plus and one of them will be a minus. And so this can be, you might have to experiment a little bit to think about what you want to do to make your factors here. So for my first example, I've got x squared plus 3x minus 28. All right, so I got to multiply to get negative 28. To get a negative number to multiply, I got to have one positive and one negative number to do that. And I need to add to get positive 3. So while I'm thinking about that, I'm just going to start each of my factors. Just use a little set of parentheses. Just take that first term, drop the squared, x and x. Can you guys think of two numbers here? Okay, he says 4 and negative 7. Does anybody know what's wrong with that? Because you're on the right track. They just need to be opposite. Okay, so this, and there's only one combination that'll work. So this has to be negative 4 and positive 7. Okay, now I keep saying to you, it doesn't matter the order that you write these in, and it doesn't. And you could switch these, but when I say switch them, I don't mean you can't switch the signs. So like I could write this as x plus 7 times x minus 4. But if I were to switch the positive and negative between those two, that would not give me back this original problem. So you got to be careful with that. So when I say you can switch them, I mean like the entire factors can trade places. You can't switch the positive and negative, though. That has to be how we laid it out to get the answer that we had for the quadratic. All right, let me try this one. So this one, first times last, I'm going to do 1 times negative 30. So I'm going to multiply to get negative 30 and add to get negative 1. And I'm just going to write my two little factors here with a little blank at the beginning here so I can think about this for a second. These are tricky, and if you get stuck, just like, what are factors of 30? So you got like 1 and 30, 2 and 15, 3 and 10. 5 and 6. Some numbers have more options than others. Obviously, 30 has a bunch of different factors. What combination am I going to use to multiply to get negative 30, but add together to get negative 1? Put all those options right there. Which one is going to add up to get negative 1? Perfect. So just one of them is a minus 6. One of them is a plus 5. And you can't switch the minus and plus. Like the minus has to go with the 6, so you add up to negative 1. The plus has to go with the 5. Is anybody having a question? Okay. Now, what I have here on the back, this is a similar problem, but I didn't have anything like this on the other side. Anytime you try to factor anything, really, we talked about this a little bit before the break. If all the terms have a greatest common factor, you should definitely take that out in front first. So before you do any kind of a factoring, look at all the terms you have there and just ask yourself real quick, like, are all these divisible by 2 or all these divisible by 5 or something like that. So if I have 3x squared minus 12x plus 9, do those three terms have any numbers in common? Are they all divisible by anything? 3. Okay. Now, if we were solving an equation, I would tell you to divide everything by 3 and get rid of it. If we are factoring, though, this is going to have to be part of our answer. So this is just like what we did right before the break. I'm just going to take that greatest common factor out in front. So I'm just going to write a 3, and then I'm going to write what's left over in parentheses. So that first term would just become a plain x squared, and then 12 divided by 3 is 4. 9 divided by 3 is 3. So if I'm factoring this, take that greatest common factor out in front first, and then we are going to factor, just like we did on the front side, just what I have, like I'm just looking at what I have in the parentheses here. So I'm just going to factor that. So in that case, I need to multiply to get positive 3, just first times last would just be 1 times 3, and add to get the number in the middle, just looking inside those parentheses, to add up to negative 4. Can you think of two numbers? If you multiplied them, you'd get 3, but you'd add them, you'd get negative 4. What do you think? Yes, awesome. Okay, so negative 3 times negative 1, right? And you don't have to write this, but negative 3 times negative 1 is positive 3. negative 3 plus negative 1 is negative 4. So when I write my answer, I do need to include that greatest common factor in the front of it. Otherwise, we should be able to multiply this back out like with a FOIL or box and get the original problem. So I do need that 3 in front of there. All right, and I got one more kind of similar to this. What I would tell you though, on this next one, if you're trying to factor this in any way, you want your x squared term to be a positive number. You don't want that to have a negative in front of that. So if you guys look at that, I got negative 2x squared minus 8x plus 42. You'd all agree with me that those are divisible by 2, right? Okay, all I'm going to tell you to do on this question, don't want that first term to be negative. So when I do this, what I'm going to do is I'm going to divide everybody by negative 2. Take a negative 2 out in front. You want that first term with the x squared, you want that to be positive. So to do that, I'm going to divide everybody by negative 2. So this will become positive x squared. This is going to change some signs here. Negative 8 divided by negative 2 would become plus 4x. And then 42 divided by negative 2, that's going to make that a minus 21. So I'm just trying to keep that squared term. I want that first term to be positive. So by divided by negative 2, I did that. All right, so I'm going to keep the negative 2 out in front, and I'm just going to set up two factors to help with this. Again, I'm just looking at what's in the parentheses after I took out a greatest common factor. So I got to multiply to get negative 21 and add to get 4. You guys think of two numbers, if you multiplied them together and give you negative 21, same two numbers, you'd add them and get 4? Yeah. Yes, ma'am. All right, so one of these is a minus 3. Oh, I didn't put the x in this one. Whoops. One of them's an x plus 7. So if I do negative 3 times 7, that's negative 21. Negative 3 plus 7 is 4. There's only one combination of those two numbers that'll work for both. Does anybody have a question? Okay, last thing I'm going to have you guys look at here real quick. This is kind of like a special case of some factoring. And so this is called a difference of squares. What do you guys think of if I say the word difference? Like, just what math term do you think of if we say, bless you, difference? If I find the difference between two things, what am I going to do between them? What do you think? Yes. Okay. So this has to be subtraction. If you have adding, you cannot use this. So you're going to see these are going to lay out, and they're going to have a subtraction sign between each of the terms. Here's the deal. This is called a difference of squares. Basically, you need to be able to take the square root of each of the terms. So I'll do one just as a basic definition, and then I got one that's a little example here. Okay, so the way this works, you don't have a middle term, right? There's no term with a plain x if you look at any of these questions below here. It's going to be a plus b. It'll just be the square root of each times a minus b. It's going to be the square root of each of the terms. You have one plus and one minus, and when you do that, I'll show you with my little example with numbers here, it cancels out that middle term. So if you're looking at a problem, this is x squared minus 36. Does anybody know what's, if I take a square root of x squared, what's that? Like if I just have square root of x squared, what does that simplify to be? X. Just x. Like x times x would give you x squared. So if I take the square root and squared are going to cancel each other out. So this would just be an x. What's the square root of 36? 6. You guys know that? Okay, so one of these would be x plus 6. The other would be x minus 6. That's the factored form. Now, I'm just going to show you this real quick on this example. If I were to FOIL this back out, though, this would be x squared. I'd get minus 6x. Then I would turn around and get a plus 6x. And then 6 times negative 6 would be negative 36. That's going to cancel that middle term, and it's just going to leave you with the x squared minus 36. I know that's what we started out with. We're just trying to put it in factored form. But literally all you need, just the square root of each of the terms. One's a plus, one's a minus. It doesn't matter the order you put it in. So if I'm looking at x squared minus 25, you guys know square root of 25? 5, right? Literally all you got to do, one's an x plus 5, one's an x minus 5. That's the factored form. It's just the square root of each one. It has to be subtraction though, because that number on the end, you get it from multiplying the two plain numbers here, 5 and -5 give you -25. You guys know square root of 49? 7. Okay, so just one of them's an x plus 7, one of them's an x minus 7. Then you're looking at the next problem going, you're an idiot, and neither one of those are perfect squares, right? 3 is not a perfect square, 48 is not a perfect square. If that's the case, though, if you don't see a perfect square, see if you might have a greatest common factor. And so, I don't know if you guys will know this off the top of your head, but both of these terms are divisible by 3. So 48 is divisible by 3, 3 is divisible by 3. I'm going to pull the 3 out in front, and then left over, that first term would just be a plain x squared. And if you take 48, divide that by 3, that is 16. So initially when I looked at the problem, I was like, those aren't perfect squares. But if I take the 3 out in front, what is in the parentheses is then a difference of squares. So x squared minus 16, both of those are perfect squares. Just one would be an x plus 4, one would be an x minus 4 to take care of that. All right, now the 2 at the bottom, we have not done any questions where we had a number in front of the x squared today. But I promise if you have a question like this, you should be able to factor it. Does anybody know the square root of 100? Do we know square root of 9? Can anybody tell me what the two little what would the two little sets of parentheses be here? If you were following that difference of squares. Like what would it be? If I'm just going to try and take the square root of each of those terms, what would you write down in the parentheses? Not a plain x. What would I write down at the beginning of each of those? 10x. Okay, it's literally, it's the square root of the whole thing. So 10x. If you FOILed this back out, 10x times 10x, the 10 times 10 would give you the 100. The x times x would give you the x squared. And then you guys already know square root of 9 is 3. So just one of them would be a plus 3. One of them would be a minus 3. All right, I got one more very similar to this. Does anybody know, how would I factor if I had 64x squared minus 121? Anybody know what would be at the beginning of each of those factors? Yes. Okay. Do you guys, and I don't know, a lot of people don't know this off the top of your head. Do you know square root of 121? Oh, okay, you guys do. Okay, so just one's a 11, one, oh shoot, I put a plus on both, my fault. One's a plus and one's a minus. I'm going to rewrite that because it doesn't look good. All right, so 8x plus 11, 8x minus 11. You do need one of each to cancel out that middle term if you were to FOIL it back out. Okay,